Welcome to another session. This is lesson 2 polynomial. We have been solving some problems from exercise 2.3. So here is the final one. Give examples of polynomial p of x, g of x, q of x and r of x which satisfy the division algorithm and degree of p of x equals degree of q of x. So in this problem, there is none of the values are given. P of x, Q of x, Q of x, R of x, nothing is given. Before assuming any polynomial for this, first I write the division algorithm, which is P of x equals G of x into Q of x plus R of x. As far as the P of x concerned, I choose any one polynomial. For example, 18x squared plus 3x plus 9. To satisfy the first condition, which is degree of p of x equals degree of q of x, if you choose g of x as a factor of this one, and it must be constant. If I choose 3, the quotient would have the same degree. For example, I divide these by 3, 18x squared plus 3x plus 9. If I divide this by 3, I cut this, then 3x plus 9 plus x, 3x plus 9, okay, sorry, not this, 9 plus 3. Or you can do simply do this way, 18x squared plus 3x plus 9 whole divided by 3, right? And here I take 3 as a common number, 6x squared plus x plus 3 divided by 3, I cut 3. So you choose either one of the way. Both ways are correct. So try to find q of x in any one of these two ways. So here I have q of x as a 6x squared plus x plus 3. Now we know the p of x that we assumed, and the g of x and q of x. Also r of x, which is 0. The next step, we should check whether our answer will satisfy the division algorithm or not. Here I substituted the respective value, and let's find out whether it is satisfied or not. So 3, 6 are 18, x squared plus 3x plus 9. Yes, we got the answer, same answer on both sides. So hence we verified the division algorithm. The same time, the first part also, the degree of p of x equals degree of q of x. So look at the degree of p of x. Degree of degree of any particular polynomial means the highest exponent, right? Highest value of between the powers, among the powers. So this is p of x, degree of this p of x is 2, and same time degree of q of x also 2, here and here. Hence we verify degree of p of x equals degree of q of x. One more thing I want to mention here, this is not the only polynomial we chose, right? P of x equals to 18x squared plus 3x plus 3. This is not the only polynomial we able to prove this relation. There are multiple choices available. There are many more polynomials able to satisfy the same relations. For example, 6x squared plus 2x plus 2 divided by 2. This will also satisfy the this first relation, degree of p of x equals degree of q of x. So one thing you make sure that the g of x, the divisor which you choose, it must be a factor of this polynomial, and same time it must be a constant, not 2x or something 2x plus 1, not like that. It must be constant and same time the factor of that p of x. This way you can choose any kind of p of x and g of x. This is what I want to mention. Let's move on to the second question. Degree of q of x equals degree of r of x. For this case, I choose p of x equals 2x4 plus 2x. For g of x, I take 2x cube. This is purely assumption. I will tell you why I assume these values. So let's find the r of x and q of x. Then verify the division algorithm. Look at here, our q of x equals x and r of x equals 2x. So it's clearly see that r of x equals q of x. The degree is same. The degree of r of x equals the degree of q of x, which is 1 equals 1. Let me check the division algorithm. P of x equals g of x into q of x plus r of x. Then I substituted the value of all p of x, g of x, and so both the answers are same. So hence we verify the division algorithm. Let's move on to the third proof, which is degree of r of x equals 0. So in this case, we can use the same p of x and g of x what we have used in the first question and continue the same procedure. Following all the steps, you don't need to skip any step or don't need to change any step. Following all the steps till you get r of x equals 0. When you conclude this relation, for example, since we get r of x is 0, since r of x equals 0, the degree of r of x also 0. This is the only step you need to add along with all procedures which we did in the first problem, right? I explain you again in detail. Okay, so as far as the third relation concern, we are going to prove degree of r of x equals 0, right? So for that, you choose the same p of x, this one, and g of x, this one, 3, and do the long calculations and find out the q of x and r of x, and also prove the division algorithm p of x equals d of x into q of x plus or, which you need to prove in all three problems. And finally, when you conclude this is what your conclusion. So degree of r of x equals 0. This is what you need to prove. So since r of x we get 0, the degree of r of x is 0 also. Yeah, hence verified our relation. That's it. Hope you understand. Thank you.